Actually, yeah, let's just get started.
Yeah,
Um,
okay.
what is disaster recovery? What does it mean in the context of streaming? What are we solving for?
Yeah, so let's imagine we have a streaming system. Okay, so you have, let's say, Kafka or Kinesis is kind of the source. People push data into that, and then you have some ETL process that takes the data out of there, puts it into your, let's say, data warehouse. And then you have a bunch of steps happening within the data warehouse. Finally, you get to tables that are aggregated, and then you have kind of a dashboard on top of that, and you have business metrics, or you have customer-facing dashboards, or all sorts of stuff like that. So this is kind of your end-to-end pipeline. And when we talk about disaster recovery, there are kind of two, generally there are two parameters that you're thinking about. The first is how much data did I lose, or how do I recover the data that I lost when there was a disaster? And the second is how long am I not available? How long am I not providing service? Or how old is the data that I'm providing service on when something bad is happening? So streaming systems are a bit different. So often, like let's say if you have a database, so you're going to have very well defined, okay, the database is down. I'm going to need to recover. Maybe my recovery process is recovering from a backup. So my backup is 3 hours old, and it takes me 2 hours to recover. So database is down. I make a decision to recover. I lose 3 hours of data. They're irrecoverable. My database disappeared. It vanished, and it'll take me 2 hours, and I'm back up. I'm back up in 2 hours with data that's 3 hours older than when the issue started. So 5 hours of data lost in total. That's kind of like very quantifiable in when you're talking about a database. When you're talking about a streaming system, it's like the data is arriving all the time. So I mean that I was kind of referencing that when I was saying like, took 2 hours to recover, so you're losing data for another 2 hours. I mean, often with databases, you're not losing data because nobody's interacting with the system when the database is down. With a streaming system, that's generally not going to be the case. If Kafka is down, the world still happens, and that data isn't aggregating anywhere. Nobody's waiting for this Kafka to come back and return a result. It's just you're just reporting to it. So if your streaming system is down, or if parts of it are down, there isn't much meaning to the rest of the streaming system because it isn't populated with data. There usually isn't a buffer that's happening before your streaming system. And if there is a buffer that's happening before the streaming system, you really could just consider that to also be part of the streaming system and part of your streaming system's overall resiliency. So, anyways, you can kind of look at it as an event is emitted, and either it's accepted or it's not. And if it's not, then it's gone. It's not going to come back. And that's kind of where the boundary of the streaming system is. And then on the other side, you have your data lake or data warehouse that contains all the data and 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 needs to contain all the data and should recover all the data. So basically, you want to when you're talking about disaster recovery for these types of systems, usually it's the recovery point in time should be all the data that was processed. So you shouldn't be losing data within the pipeline because each of the elements, so Kafka should maintain the data. It should keep the data that did arrive, and any data that didn't arrive is just lost. So it's not like there isn't a point in time recovery exactly to that. Does that make sense?
Yes, and maybe it would be helpful, I think, to talk about like what are some disaster scenarios, and like are we strictly talking about disasters that are out of our control, so like Kafka being down, right? Or are we talking about internal disasters as well?
Yeah, I mean, that's a good point. So, okay, so first of all, let's give an example. Like the kind of most common example that people are going to talk about is an AWS region or availability zone goes down. So servers aren't available. usually this is going to cause Kafka to go down, also your data warehouse to go down, also your servers, your internal servers, your website, everything goes down. Now what's happening? So Kafka's down, you're not getting any new data. You're also not processing anything. Your pipeline is frozen because you don't have any servers or anything. And this is basically your state. Failing over, let's say if you wanted to have a hot failover to a different region, you need to basically replicate all of your infrastructure. You need Kafka to come back, you need your ETL process to come back, and you need your data warehouse to come back. All of them need to have kind of a hot swap to a separate region for that to work. Let's say you're not doing that and you wait, and now AWS recovers. So now Kafka comes back up, it's getting events. Your ETL process needs to come back up and process those events, and your warehouse comes back up and continues getting events to the target. None of these steps should lose any data along the way. So there shouldn't be, like, kind of the design of these distributed systems on the lake are such that you shouldn't be losing any data when there is a disaster. It should just stop processing, essentially. So that's kind of the design goal that you're usually going to see for lake systems is how do I just make sure that I'm resilient enough that when everything comes back online, I can continue processing where I left off.
So the source hasn't stopped producing data, right? While everything else is down. And so are you telling me that when everything comes back online, we're gonna get data from when we had stopped receiving data? Or like, is there a hole? There's not going to be a hole at the end?
So it depends. So if, like, sometimes people sending data buffer the data. So if I can't send to Kafka, I'll store it on my own server, and then eventually I'll flush it. I mean, if my servers also went down there before Kafka, then there's nowhere to buffer it. But I mean, it really depends on the pipeline. If, like, basically the question that you're asking is, after a disaster, do I suddenly get a spike of data into my streaming pipeline? Or am I just going to lose a bunch of data and continue as though nothing happened? And it just depends. Like, it depends on the source systems. This is usually not going to be in the control of the person designing the ETL pipeline or let's say the streaming pipeline. But yeah, it can be one or the other, basically, depending on if there's buffering happening upstream or not.
Got it. Okay. And I mean, if there's no buffering happening, the data hole we can't do anything about it ever.
Exactly.
But if there is a spike now, am I going to so in the streaming context, are things just like sort of piling up, or are we gonna get, okay, this is happening right now, we're getting those, and this has happened in that downtime, and we're getting those as well? Like, are we gonna get everything in the same stream at the same time, or how does that work?
So this, again, very much depends. Usually, most systems are going to let data pile up, and they're going to process data in the order that it arrived. This avoids a lot of complexity around out of order data, and, like, often aggregates are going to be incorrect. Like, often the order of the data matters. So processing the latest data first and then processing the data that piled up later is both technically complicated and also doesn't necessarily give you the results you want. But also, the streaming system should scale up. So it should add servers. This is kind of the promise of the lake, that if I suddenly get a spike of data, I can just add more servers to handle it. Whereas a database would have kind of a fixed size that wouldn't allow you to easily do that. And then it means that processing that backlog can take a very long time. Because the database is not sized for the spike; it's sized for the steady state. Yeah, and this should be true for every step in the pipeline. So, I mean, generally Kafka isn't going to be a bottleneck, but if you're using, for example, Kinesis, then you can scale that up. You can generally scale up your ETL. If you're using Spark, if you're using Upsolver, it should scale up seamlessly. And as well, the data warehouse should also allow you to scale up elastically to handle higher workloads if necessary. Yeah.
Thank you. And I interrupted you before you were going into internal disasters.
Yeah. So external disasters are kind of simple in the sense that that it kind of is what it is. Like the data was either generated or not, it piled up or it didn't. But the recovery, since it's a streaming system, is just going back online. There isn't much that you're going to need to do. So there are some situations where, let's say, if you're doing a daily aggregate, and maybe your warehouse didn't crash, so it did its daily aggregate, but it didn't include the data, so you need to correct it. But for the most part, most of the ETL, depending again how you designed it, most ETLs should just continue running as is without any intervention. But what happens if you have a bug? Like what happens if some developer committed code and now your ETL is reading the data, but it's discarding it because the primary key is null? So now you have your source data, you have the data landing, it's getting all filtered out, then you have your ETLs and they're all getting incorrect data, they're not getting any input. And then that's what you see in your dashboards. And you often find out about this many hours later when a customer complains, hey, wait a minute, this doesn't make sense. People spent more than $3 in the last 2 days. And then what do you do? So here it really depends on how much you're leveraging the lake. Upsolver is a very big proponent of store all of your raw data as is, as it arrived in the lake. It's very cheap, it's compressed, and this is exactly what gives you the capability to very quickly roll back and rerun your pipelines on top of this stored data with the fix. Now, this fix can be a lot of things. If the primary key didn't arrive in the source, then maybe you need to generate a primary key. If it was filtered out because a developer committed a bug, then maybe you just need to roll back that commit and then rerun the pipeline on historic data. But any of this requires that the historic data is available. Generally, the data arrives, let's say if you're using Kinesis, it has a 1-day storage and that's it. It can be extended to a week, but I mean, it's not, let's say this is not your long-term storage. Similar for Kafka, it's expensive to keep a lot of data in Kafka, so mostly you're going to want to flush it into the lake where it's cheap. So Kafka is usually going to have a little bit of storage, hours, days, and then the lake can have months or years of storage, depending on kind of how old is relevant data for you. And then all that data, either sitting in the lake or sitting in the warehouse, allows you to recover by just rerunning your pipelines, essentially rolling them back to a previous time. You don't need to develop anything. You can just actually continue from where you left off. I think that's a very powerful differentiator for organizations that, like, generally you have. A very good example of this is S3 Glacier. So there's this storage. S3 is very cheap in general. It costs $23 per terabyte. But then you have Glacier Deep. Deep Archive, which costs $1 per terabyte. So it's like 23 times cheaper. And it's very hard. Like, it takes a long time to recover the data from there, like 12 hours, and there's transaction fees and whatever. But the idea is that you can store a ton of data there, and then when you have your disaster, you'll be able to recover it and use that data. So that sounds great. Like, it sounds like an amazing promise. Cheap storage and all your data. The issue is that when you have a disaster, you don't have time to start developing new processes for pulling this data out. And this isn't like, the deep archive isn't part of your normal pipeline. This is like, okay, I put the data there. And unless you've actually built out a lot of infrastructure in order to rerun your pipelines based on data coming out of deep archive, which is essentially rebuilding your pipelines for that, in the situation where you have a disaster, it's not really going to be feasible to access this data. So usually, like, if it takes you more than 8 hours to recover from something, then often people are going to start talking about like, does it make financial sense to recover? Like maybe we just want to give up and move on and apologize to our customers. So like a big important part of disaster recovery is how how prepared are you, or how easy is it to actually do the recovery? Because as that becomes worse, less likely that all this stuff is even relevant, and might be checking a box, but like in reality, you're not actually going to get any benefit from it.
That makes sense. Yeah, this is reminding me of particle physics, where we would have a copy of our data on tape, which is hard to reach, but at least we knew that it existed.
Yeah. Yeah, no, I definitely, I remember like this was maybe 15 years ago in the army that we had these tape backups that they were somewhere. And like you have to requisition or something. And like when there was a disaster, those tapes were not available. Didn't work.